Okay. Good afternoon, everyone. Welcome to lecture 6, this term, 6 of this module, introductory programming module. Today the topic is about loops. How we can construct, how we can write loops in Java. Loop basically is any mechanism that allows us to repeat the same thing over and over again. That's why it's called loops. So let's work cover so far. Good things. First 2 weeks it was just introductory and how to use Eclipse, how we can write that system output line statement to write the hello world program. Week 3 we started with variable and expression, and we studied different types of data types that we have. What we call them? We call them primitive data types. Okay. The constant. How we can create a constant? Final at the beginning. Same thing, same way that we create a variable. Data type, name of the variable, we put final at the beginning. Okay. And we studied what else? Conditional statements. Last week we studied conditional statements. So conditional statements, it was actually 2 weeks. So conditional statements. Week number 4 was if, else if, all the variation that we have with if. How many else can we have? As many as we want. And we can end with the optional part, which is else. Okay. Last week we covered the other 2 types, which are the switch statement that has multiple cases, and it has default as a default option as well. The case itself can be what? Three options. So we say switch something, we have expression that will give us a value. This value could be one of 3 things. Say switch expression. That expression will give us a value. After that, we have case something. So, what are the possible data types for this output from the expression? Again, string, option 1, integer, or no, character. Yes, sorry. Yes, and we studied the question mark column that we can use with conditional assignment. Remember, I said that conditional assignment. What is an assignment statement? Any statement that has one equal sign and has semicolon at the end. That we call assignment statement. We take on the right side, we put on the left side. Okay, always that like this. The right side could be a very complex expression that will give us a value on the right side. It could be very complex. Okay. But eventually it will be evaluated by Java and give us one value. We take that value, we put it on the left side. What do we have on the left side? One variable only, exactly. One variable. Now, today we look at loops. So loop is, as known, we call it one of the control loop or loop statements. The loop statement, you can repeat the same code multiple times. Because, for example, if I have like Moodle University, for example, they have like around 1,500 to 2,000 employees, and they want to calculate bonus, for example. They never get bonus, by the way. But if they want to calculate bonus, do you think they will go through the record of each employee individually? No. They create one logic, one block of statements that will calculate the bonus, and that code will go to the database of employees, and it will read the basic salary, and based on the basic salary, it will calculate the bonus. One at a time. It will go through the records of the employees one at a time. So it's a loop that will go through all the records one at a time, calculate the bonus, and after that, we get it back to the people they need to make the payment. So that's one example. There are many examples. Loops, we use it for many things. Okay, I'm going to give you a few examples now. One simple example, I will show it to you in a second. Loop. Back to the block while keeping track of each iteration with the decreasing and decreasing. With loops, we can go up or down, depending on the logic that we want to implement. If I want to count, for example, from 1 to 10, I need to go up. If I want to count backwards from, for example, from 20 to 10, then I need to decrease. I need to go down in this case, not go up. It will become clear in a second. For example, I have this example here. System output line from 1 to 10. If I ask you to do that, you will most probably write the first one, copy paste it, and keep changing. Correct? If I ask you to add 100, you will do the same, you might do the same, and keep changing. If I do it, ask you to do it 1,000. If you are very stubborn, okay, yes, I want to do it manually. But you might make a mistake, or mistakes actually, not only one mistake when you do this. If I have to do it 1 million, 100% you will commit suicide. Okay, at some point. You won't be able to do it, okay, manually. And that's why this is not a good idea. The good idea is to use a loop if I want to do this in a more proficient way. And there are 3 types of loops in Java, not only one type. Just like we have 3 types of conditional statements, we have 3 types of loops in Java. The first one is the for loop. Okay, for loop, we know the starting point and we know the ending point. We know that I'm going to start from 1 to 10. I'm going to start from 100 to 1,000. I know where I'm going to start and I know the ending point. Okay. The other 2, so this is repeated specific number of times. That's what I'm saying. We know exactly how many times I want to repeat it. The while loop, that's another one. We use it when we keep repeating it as long as one condition is true. So as long as the condition is true, we keep repeating. When the condition becomes false, we stop. We don't repeat anymore. Okay? So basically, it depends on the condition. You'll see an example about this will become clear, hopefully. The other variation of while we call it do while. It's very similar to while with one slight difference that we'll look at later in this lecture. Is used with a lot of executing while some condition is true. So basically, it's exactly the same as while, but with slight difference, very small difference that we'll understand it later. But again, we have 3 types of loops in Java: the for loop, the while loop, and the do while. Yes, I'm saying here the while and do while seem the same, but one difference that we will investigate later. The for loop, the first one, the most famous one, is always like this. We have the keyword for. Remember that one of the words that I gave you in exercise number 4 in lab number 1. For. I asked you to declare a variable using the name of the variable is for. Were you able to do that? No. Why? Because it's a reserved word. It's used by Java for loop. So we cannot create a variable called for with the same name. And we have the starting position. So we have a variable equals starting position. We have semicolon here. After that, we have a continue condition. We decide based on this condition whether to continue looping or not. After that, semicolon. After that, if you are going up, we use the increment. If you are going down, we use the decrement. Okay, again, we have the starting position, starting point. We have a continue condition, and we have either increment or decrement. If I'm going from 1 to 10, I need to use increment. If I'm going from 10 to 1, I need to use decrement. Correct? Makes sense. And when the continue condition, as long as the continue condition is still true, I do the code here. And the counter will increase or decrease. You will see. So var is the name of the variable. Any variable that you might have, it has to be integer variable. When we use counting, counter, any counter has to be integer. I cannot use a counter that is not integer. Okay? I cannot use a counter, for example, double counter. I can use 1.1, 1.2, 1.3. Doesn't work like that. The counter in Java always has to be integer value. 1, 2, 3, 10, 100, 101, 102, etc. Always has to be integer. Start is the initial starting value for the loop variable. This is what var here, what we call the loop variable. That loop is only for the loop itself. We use it for the loop. Continue condition is a test. We'll give you true or false. Just like x greater than 1 or x greater than or less than or equal to 5, etc. Any logical condition, any logical expression that it will be evaluated to true or false, always. Yeah, exactly. So if it evaluates to true, the loop keeps repeating, running code over and over again, as long as the continue condition is true. When the continuing condition becomes false, we exit. We go to anything that we have after the for loop, after the bracket of the for loop. So that will add a little bit complexity compared to what I am seeing already with your code. Sometimes I see that you're missing closing bracket, okay, for the class or for the main method. Now, if you write statements here, then you open closing bracket and you have to close it. Always the number of open curly brackets and the closing curly brackets, it has to be what? Even, first of all. It cannot be all. And they have to be equal. So same number of opening brackets as the number of closing brackets. Otherwise, it's not balanced. I did show you this before. Yes. Okay. What else? Incremental decrement, yes, depending if I'm going up or down. If the starting point is smaller than the ending point that I have in the condition, then it's increment. If the starting point is greater than the value that I have in the continuing condition, then it is decrement. I'm going down. Okay, either I count up or count down. For the increment or decrement, we can use, for example, if I want to increase the value of x by 1. The normal way that I know it is x equals x plus 1, correct? So in this way, I'm increasing the value of x by 1. X equals x plus 1, correct? Yeah. If I want to decrease the value of x by 1, x equals x minus 1. Good. But in the for loop, we can write this here if I want to increase or decrease x equals x plus 1. Or for the loops, particularly, we use this short syntax. X plus plus is the same as x equals x plus 1. X minus minus is the same as x equals x minus 1. Okay. Everything will come clear when you write the code. For example, this code here. A for loop for if the variable is the loop variable. Where is the loop variable here? I. The loop variable, what? What? No. What is it? What is the code? What is the name of the loop variable? I. The loop variable here, if it's not declared before in my program, then I have to declare it here in the for loop itself. Okay, let me open Eclipse. Okay. Loops. Okay. So I'm going to write a for loop. How to write it? First of all, the keyword for. We open round brackets, and here I need to have a loop variable. The options either to have int I here is fine. After that, here I can start in the for loop itself. I can do this I equals 0, semicolon. The continuing condition. I want to repeat this. I want to repeat something, let's say for 5 times. Then I less than or equal to 5. And after that, I plus plus. Okay, so this out. This out. I on math. Okay. So this code. This is the option, either to declare the loop variable outside, or if I don't have this outside, as you can see here, Java will complain. because the loop variable is not declared yet. So either to declare it before or declare it here. I can do that. Okay? So either here or outside. What's the difference? Who can tell me what the difference? There's one difference between declaring the variable here or declaring it outside.
Declaring the cycle only for the two.
Exactly. Exactly. If I'm doing this, int I here, declaring the variable in the loop itself, is only accessible by the loop. If I declare it outside, it's accessible outside and by the loop. Okay? Exactly. It's about visibility. Okay, so what's happening here? Let's have, always when you have a loop, you need to have a counter on the side, either pen or paper, however you like. What are the starting value of I? 0. So I equals 0. This is how for loop works. We go to the condition. When I is 0, is it less than or equal to 5?
Yes.
Then it is true. Okay, so it is true. When it's true, we go inside and we run the code that we have. It might be 1 line, it might be 1 million line. We don't care. Anything inside the loop will run. Okay? Clear? Between the brackets of the loop. And forgot to mention this. You see how the loop, the start curly bracket for the class here and the ending here. The starting curly bracket for the main method is here and the ending is here. The starting curly bracket for the for loop is here and the ending is here. What I've seen from you, not with loops, but different things. For example, if I go and delete this. Okay, I've seen this many times. That's why I'm mentioning over and over again. It's not balanced now. Okay. Okay. Now, so we did I equals 0, and we check the condition is true, and after that we run this code. After that, where do we go? No, after that we go to increment or decrement. So I becomes what? I becomes 1. When I is 1, this is the condition 1. Is it less than or equal to 5?
Yeah.
Then we go inside the loop and run the code. We print again. So that's 2. And we go inside, run again. Now, we finish running again. We have in the output, I am Iron Man the second time. Now, where do we go next? Increase the increment. Increase the value of I by 1. I becomes what?
2.
I equals 2. 2, is it less than or equal to 5? Okay, so it's 2. And we print, after that we increase the value of I by 1. I becomes 3. Okay, 2. I becomes 4. Okay, it's 2. I becomes 5. I equals 5. 5, is it less than or equal to 5? Yes, then it is 2. I becomes 6. 6, is it less than or equal to 5? No, then that's false. We exit, so we don't run anymore. In this case, I don't have anything else to run here, so it will finish the program. But if I have any other code here, it will run the rest of the code. So for example, here. Hello, Iron Man. You will see how many times it will print. 6 times. 1, 2, 3, 4, 5, 6. After that, it finished the loop and went outside and continued running the program. Hello, Iron Man. Correct? Do you want to understand that? Okay. Now, question. What if I want to print only 5 times? Say again. I Say again. One option. Yes, that's one option. Your colleague said that if I want to print I am Iron Man only 5 times, then I can start from 1. So we go 1, 2, 3, 4, 5. That's one option. Let's run it and see. 1, 2, 3, 4, 5. Exactly.
Zero, you can hold it time, so it will be only less than 5.
Exactly. So if it's 0, if I want to keep it 0, that's another option, is to remove the equal sign. Okay, because I is 0. Is it less than 5? Yes. 1, is it less than 5? Yes. 2, is it less than 5? Yes. 3, is it less than 5? Yes. 4, is it less than 5? Yes. 5, is it less than 5? No, then it's only 5 times. Do you understand that, guys? So let's run here and see. 1, 2, 3, 4, 5. Always, if I want to check, I can do this, by the way. I can use the loop variable when I want to print something. For example, I, like this. So what I'm doing here, I'm printing every time the value of I. Let's see. 0, I am Iron Man. 1, I am Iron Man. 2, I am Iron Man. Because what I'm doing here, I'm just combining two things. Combining the value of the loop variable I with the text, I am Iron Man. Or if we do the other way, start from 1, it will 1, I am Iron Man. 2, I am Iron Man. Of course, I can do this in any shape. For example, I can construct any shape I want. For example, if I do this, you will see that it has a nicer 1 bracket, I am Iron Man, 2 bracket, I am Iron Man. You can play with, you can construct this any way you want. You understand, guys? Any question about this? Could you please write this? I just want to see how you get along with writing for you. Could you write this? It's very simple, I know. I just want to see. Please finish, please raise your hand if you finish. Who has not finished yet? Who has not finished yet? Finished yet? Okay. Who else? Well, oh, certainly not on here. We do like everyone. Now we are starting another conversation. My fail, by the way. My fail. I didn't write I am Haris Muhammad guys. I am Iron Man. Yeah, apparently. Second failure already. In the module. Straight, no worry. Straight? I've traded it. First question last forever, you know that. Yeah. Okay, clear everyone, guys? Yeah. Okay, let's do something here, guys. Please pay attention. Everyone, please pay attention. So I want to count 5 times, but I don't want to count from 1 to 5. I want to count from 5 to 1. Okay, so if I want to count from 5 to 1, first of all, I have to change the starting point because this is where we put the starting point. So I want to change it to 5. If I do this and run, what do you think will happen? Are you sure? Okay. Let's see. 5. Okay. Then what else do I need to change? Say again? Change it to 0. And I minus. I'm going with what your colleague said. Let's see what's going to happen here.
We don't have to change 0. We don't have to change 0. Only the command. You should change the sign. It should be greater than.
I don't have to change the 0. Keep it 5 here. That's what he said. No, I'm just a second. I'm going with what he said. If I do this, let's see what's going to happen. Why is doing this? Because it keeps checking. 5, is it less than or equal to 5? Yes. Then after that, decrease 5 by 1. So 4, is it less than or equal to 5? And that's why it's going minus. It becomes 4, 3, 1, 0, minus 1, minus 2, etc. If you want to stop this, you can stop it from here as well. Okay. So what else do I need to change then?
Change the greater sign. What is the sign?
Put 0 here.
Yes.
And
Change the sign to greater.
Greater, exactly. So these are the things. We have to change 3 things basically. So first one, let's go back to what it was before. So first of all, finished. First of all, I have to change this, the starting point. It has to be higher, greater than the ending point. For example, this is 5. This has to be smaller, let's assume 1. And then I have to change the sign here because now I need to check. 5, is it greater than or equal to 1? Yes, then do the code that we have inside. And we have to change this to minus minus because now I'm going down from 5 to 1. 5, 4, 3, 2, 1. Okay? You understand that, guys? So please change it and tell me what you get in the code. If I run now, you will get the same code that I have. So 5, 4, 3, 2, 1. Get the same good results? So I have to change the starting point, we have to change the ending point and the sign here, the condition, and we have to change it to minus minus. If you are going up, then it's plus plus. If you're going down, it's minus minus. I think that's here, and I hope it makes sense to you. Finished, guys? Yeah. Any question at all? Is it working for all of you?
Yeah.
Are you sure? Okay. Anyone still writing anything? But I can see people still writing something. Finished? Okay. Let's go back to the slide. So this is the output here. The output from the first one, I just same code but with different. So count is combining with the value of I. So you can see how we can combine the value of the loop variable. Okay, so count is with the value of I from 1 to 4. That's why you get count is 1, count is 2, count is 3, count is 4. Now, if I want, this is exercise. If I want to modify the code to print from 0 to 1000, inclusive, what do I need? Raise your hand if you know the answer. Raise your hand. It says 0 to 1000. So if I want to modify the code that I have here to print from 0 to 1000, what do I need to change? Raise your hand if you know the answer. Yes.
Start value.
The start value would be what?
0.
And
Last value. And then value
1000. Anything else?
No, it will be giving us 1001 value. So
Yes. Do I have to change anything else?
yeah. We can remove the equal.
Do I need to change anything else? I'm asking. So you said that I need to change this 0 and this to 1000. Do I need to change anything else?
The equal sign we can remove to in order to print.
From 0 to 1000, I need to keep the equal sign. Because if I remove the equal sign, please pay attention, Zakaria. Your colleague is saying, if I want to print this, let's go back to how it was. Let's from 1 less than equal to 5. And I want to make it print 1000 times. Okay, so your colleague said that I need to change this to 0 because the question is asking here, change it from 0 to 1000 inclusive. So I want the 0 and I want a 1000. Okay, exactly. So I change this to 1000 because that's what it means, inclusive. Both of them part of the range. Okay, so if I run this, I get the 1000 here. That's what I want. Okay, do you understand that, guys? Okay. Change the code, this code, to print your name 4 times. What do you need to change? Yeah, and I said that we must always use integer. So I'm asking here to change the code that I have here to print your name 4 times. Yes. Anyone? Do I need to check anything in the for loop itself, in the for line? No, exactly. Where do I need to change? System outline line your name. It will print your name 4 times. Correct? You understand that, guys? It's very simple. Nothing complicated here at all. Okay, Harris? Okay. Modify the code to count down from 20 to 1. This code. What do I need to change? Start 20. What else?
Greater than equal to 1.
Greater than or equal to 1? I minus minus. Exactly. Exactly. So here from 20 greater than or equal to 1 and minus minus because I want to do so. Let's see. That's exactly what I have from 20 to 1. Clear? Good. So this flow chart shows the same thing that I sent you earlier. Guys, please pay attention, everyone. So when we start with any for loop, first of all, we start with the starting position, starting point of the variable. So set variable to starting point here. After that, go to the condition. Is it true? If it's yes, then do something that you have inside, whatever that something, printing, calculating, doing whatever you want. And after that, we go to apply the increment or the decrement. In this case, this is the increment. After that, we go back to the condition. Is it still true? Then do something again. Okay? And apply increment again. Condition. We keep doing this until the condition becomes what? False. False. If when it becomes false, it goes out and go to the carry on here. The code that I have after the for loop itself, after the ending bracket for the for loop. Clear? Okay, that's exactly what we did here. So that's here, that's the code that I have after the for loop. Let's add just here. So when I print this, it will keep doing this until one after that it will exit. It will print one empty line. After that, it will print hello Iron Man. Clear to everyone?
Yeah.
Okay. And that's the example that I have here. I'm declaring the variable x outside the for loop, which is fine. I said to you earlier that's fine. We can do that. So for x equals 0, start position 0. X less than 10. When 0 is it less than 10?
Yeah.
Yes. Then we go inside. This print this output. So 0. 0 is it less than 10? Yes. Then do something. What is the something that I'm doing here? System output line x in loop equals 0. Apply increment from here. So x becomes what?
1.
X becomes 1. 1, is it less than 0? Less than 10, sorry?
Yes, true.
1, is it less than 10? Zakaria? Okay, then do something. And keep doing this. X equals 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 less than 10?
Yeah.
Yes, print. Increment. X becomes 10. 10, is it less than 10?
No.
No. Then I go here, carry on. If I have any other code outside the for loop, it will continue that code. Is it clear to everyone?
Yeah.
Any problem with understanding this at all? It's very weird now. It's like meowing now. Someone is saying this. Answer. That's Sufyan. Now. It's gonna be weird, even weirder when you hear it in the recording of the lecture. Okay, this is the order here. Set the variable x to 0. Test if x is less than 10, yes. Do the code that you have inside. Increase x by 1, so x becomes 1. Test the condition again, and so on, so on. You keep repeating this, and you do that from 0 to 9, so you print 10 times. Correct? Any question about this at all? Okay, example 2. If you know the answer, raise your hand. Only raise your hand. What are you going to get from the output here? That's the video now. What's the output? Yes. Discussing this, what's that? Yes, going to be. Yes. Anyone, just start a new thing. Yes. It's going to be. I don't know, I'm asking. Don't answer my question with a question. In the exam, I give you a question. You write a question to my question. That doesn't work.
We have the star value 5.
Okay.
The condition is
Exactly. This
x greater than.
think logically. 5. Is it greater than 0?
Yes, it's true.
Yes, 2. Then I do the code inside. X in loop equals 5.
Yeah.
After
Then
that,
we
x
get
becomes
4.
4. 4. Is it greater than or equal to 0? Yes. Then it will go from 5 to what?
3, 2, 1.
And 0.
Yeah, it equals 0. It depends 0 also. Yeah.
Okay, because we have equal sign. So it's x in loop equals 5, x in loop equals 4, x in loop equals 3, x in loop equals 2, x in loop equals 1, x in loop equals 0. After that, it will print x out of loop because we continue running the code here. Correct? Okay. Do you understand this? Anyone doesn't understand that? Do you all understand that?
Yeah.
Some people didn't answer for either one. Do you understand or not?
Yes.
Any question for this at all? Okay. If you know the answer, raise your hand. Raise your hand. Don't think out loud. Okay?
No.
Still thinking out loud. If you do that in the exam, I will kick you out of the room. Not you, I'm hearing someone. Yes.
X out of loop is equal to 0. Right. Yeah.
Yes.
It was going to give you an error.
It will give you an error.
It will give the outside. If X does only print the outside. So he has the out and not for the error.
So I'm asking you said that it's going, you said that it's going to give an error. Is it going to give an error?
No.
So what is it going to print?
X out of loop is equal to 0.
Keep saying something. This thing that's not gonna happen. First time you say error, second time false. It's not error or false. Think logically. X equals 0. I initialize the value of x by 0. Okay, to 0. But in the loop, the starting point, I said x equals 10. Now 10. Is it less than 5? No. Do I run the code inside? No. I go outside right away here. And I write system out print line x out of loop equals what?
0. The value also the loop.
No. No, x equals 10. Because this x is the same, that x is different. It's not, it's different x.
But isn't the loop didn't run?
Okay. Let's run and see. So your colleague said that since x is out of the loop and survives to 0, it will print 0 at the end. But that's not true, because when I said x equal to 0, I went inside and I changed value of x to become 10. So 10, is it greater than, is it less than 5? 10, Zakaria. Is it less than 5? Then if it's not less than 5, the condition here true or false? I'm asking Zakaria. You know Zakaria?
Yeah.
Zakaria, is it the condition is true or false? Then the condition is false. Do we run the code here? Then we go to outside, correct? And that's why we print the value of x in the memory. Still, I have the value of x is the same x. If it was different x, then it will complain actually, because I cannot have two variables x. Do you understand that? Clear to everyone? Any question? Okay. And x out of loop equals 10. Question. If you don't answer, raise your hand. Don't think out loud. Just don't. Okay? Just raise your hand. Someone new. There's a pigeon here. Attending the lecture. Yes. Exactly. 10%. After that, I'm saying I starting from 0. When I is 0, is it less than or equal to 10? Yes, from 0 to 10. Exactly. Okay, what will happen if I replace I plus plus with this I equals I plus 3? Again, if you know the answer, raise your hand. It's not I plus plus anymore. I plus plus increases by 1. Now it's I equals I plus 3. Yes, Zakaria. And what will be the result? Yes, so what will be the results? 0, 3, 6, 9. Do we have 12? Do we get 12 in the output? Okay, because it will be not exactly, it will be false, so it will not print. Clear? Good. And that would be output 0, 3, 6, 9. Okay, let's just see this. Which slide is this? 17. Okay, let's take a break. Let's take a break after 20. After that, we continue. In progress. Recording in progress. Recording in progress. Okay. Oh. It might be within inside if you could don't continue with the sentence that you were about to say. Okay. Someone said. Okay, let's continue. So now, do you remember modulo from lecture number 3? What does it give us? The remainder of division. So 11 modulo 1, modulo 3. What is it? 2. Why? Because how many things I have inside 11? 3. And what is left? 2. That's why it's 2. Now, I can do this 1 modulo 2. If I have the left side smaller than the right side, then it will always give me the left side. Okay? So in this case, 1 modulo 2, the left side is smaller than 2. 1 smaller than 2, that will give me the left side itself. 2 modulo 2, how many 2 inside I have inside 2? What's left? 0. 3 modulo 2, how many do I have inside 3? What's left? 4 modulo 2, 2, and the left is 0, etc. So what do you notice? Even numbers, exactly. Even numbers, will they give us 0? Odd numbers will give us 1. And that's how, so each even numbers divided by 2 have remainder, the remainder equal to 0. And that's what I can do here. So now if I have this variable x that has value of 12, I can do this. If x modulo 2 equal to 0, because I'm testing here, if the remainder of dividing the number by 2 equal to 0, then that's even number. And that's why system output line x is an even number. Now I can take this, and before I do that, how can I change this to give me the odd number?
Equal to 1, equal to 1.
Equal to 1, or not 0. Exactly. Equal to 1 or not 0. Because equal to 1 means that it is odd. Odd number. Not 0 again is, it's basically odd. So that's one of the options here. Now I can take this condition and put it inside a loop. So the loop starting point is 0, ending point is 20, and I'm increment. So if we go back, this always remember this in the back of your head. We start with here. We test the condition. If the condition is true, we do the code inside, and we apply the increment. Test the condition again. Keep doing this until this becomes false. We exit. So if you apply the same logic here, we start from here. X equals 0. 0, is it less than or equal to 20? Yes. Then we go inside 0 modulo 2. The left side is smaller than the right side. 0 modulo 2 gives us what?
Left side.
If the left side, I just mentioned earlier, if the left side is left side here smaller than the right side, we get the left side itself. Okay? So it's 0, not 1. So system output line, the value of x, which is 0. And after that, 1. We increase the value of x by 1. So x becomes 1. 1. Is it less than or equal to 20?
Yes.
Go inside. 1 modulo 2 gives me what? 1. Is the condition is true here? False. So basically, I don't run the code here. 2 less than or equal to 20? Then go inside 2 modulo 2 gives me what? Which means that this is true. I go inside run the code. If I keep doing this, it will only print what? Even numbers, exactly. It will only print 0, 2, 4, 6, only the even numbers. Clear to everyone? Any question about this, guys? Could you please write the code here? Write the code. Who has not finished yet? Who finished? Yeah, as usual, some people they don't raise their hand. By the way. Ask me, he asked me, is it you are this ready? This thing that you do is to go to take my salary. Now that's the kind of thing that I go on. The photo, what does the sound of the not only that, graphics that the photo. No, I just want, I don't want to sneak one out. No, it's fine. When the photo, what is the sound of the photo, open the market, the photo, when, yeah, I'm going to look at the photo because it's not like that. I'm going to wait. The photo that opening, turning on the photo. That's very what you have to do. Look at the code that I have there. Look at the code carefully. I have the photo, the opening kinematics of the photo. It's surrounding everything. If statement, this photo doesn't have semicolon there. And it has its own brackets, which you don't have. I don't know why you're doing this. Don't delete this. You don't have to delete this. I don't want to see it. Look at the code there. The photo. We open the curly bracket and we have the curly bracket. Now the if statement. Where are the opening curly bracket and the closing curly bracket on the if statement? The if statement. How come the opening curly bracket for the if statement is before the if statement? It's not correct. Please look at the code. Look at the slide. The for loop. The for loop. The curly brackets for the for loop. Where are they? It's color coded. Where are they? The for and at the end. Now, where are the curly brackets in the if statement? Is it the same what you have? Then fix it. Fix it. You don't have the same thing that you have there. But the problem with the code is that it's not aligned. It's not, the indentation is not correct. So not correct. You see that? It's going to see what we have there. Right now. Is it only for everyone? Anyone facing any problem? Okay. Is problem for everyone? Anyone facing any problem at all? Now we have something called a close algorithm. Pay attention. Give attention. This close algorithm is very old, apparently. It dates back to 300 BC. It's very old. It's 2010, so basically 2324 years old, which is, yeah, it's very, very old. Okay, so please pay attention. What do we do with this algorithm? This algorithm, we use it to find something called highest common factor. Highest common factor. Do you know what that is? Go back to high school. What is high common factor? You say yes and okay, we used to.
No, I just.
And he doesn't know. Highest common factor is the biggest number that we can use to divide two numbers. For example, 500 and 10. What is the highest common factor? Highest integer number that we can use, the biggest integer number that we can use to divide 500 and we can use to divide 10 as well.
Divide 10 and 500 both.
Yeah.
So,
It's 10. Yes.
10.
Okay. What about the highest common factor or the highest number that we can use to divide? I have the example here actually. I can't remember them. So it computes the highest common factor, okay, between two positive integers. Both of them, they have to be positive, okay? So largest positive integer that divides number A and B without any remainder, For example, this one, example, yes, I was trying to remember this. The highest value that we can use to divide 65 and 26 is 13. The biggest number that we can use to divide both 65 and 26 is 13. 13, let's see here. So 65 divided by 13 gives us 5, and 26 divided by 13 gives us 2. Correct? Without any remainder. Same thing here. Highest common factor for 27 and 90 is 9. 9 is the biggest number that we can use to divide both numbers. You understand the concept here? That's what highest common factor is. Now, a close algorithm helps us to find that value. Let's see. Note that the value of A and B change as you follow path. Okay, it's here. We start from here. Input two integer numbers, two positive integer numbers. Any two positive integer numbers. Calculate the modulo. Modulo. Remember that? C equals A modulo B. The two positive numbers, C A modulo B. Now we go here. We follow the arrows. C is equal to 0. If yes, display B as the highest common factor. If no, then change the value of A to be the value of B, and change the value of B to be the value of C. Okay? And calculate the mod again. Is it equal to 0? If yes, display the new value of B, which is C, as the modulo, as the highest common factor. Otherwise, keep doing this. You understand? Okay, let's run the algorithm once with 65 and 26. So please pay attention. A equals 65 and B equals 26. Correct? Now let's calculate C. C equals what? A modulo B. So 65 modulo 26. How many 26 I have inside 65?
2.
What is left?
3.
Say again? 3.
30.
13. Now, 13, this is basically C. Is it equal to 0? Is it equal to 0? No. Then what do? I go set the value of A to be the value of B. So A becomes what? 26. And B equals to what? Set A to be B and B equal to C. So what is B? B equals 13. Now calculate C again. C equals 26 modulo 13. How many 13 do I have inside 26? Do I have any remainder? No. Then that's equal to 0. So that 0, is it equal to 0? Yes, so here, first time it was false. This time it's equal to 2. Since it's equal to 2, what do? We display B as the highest common factor. Clear? Yep. So display B as the highest common factor, which is basically 13. And that's what. Do you understand how the algorithm works? Yeah. Okay. Question. You know the answer? Answer. You don't have to raise your hand. Do I know in advance how many times I need to run this loop? If I don't know in advance how many times I want to run something until I find the answer, can I use for loop? No. Because for loop, we only use it when we know exactly how many times I want to repeat something. And that's why we need to use something called while loop, while condition. Do you understand that, guys? With for loop, we only use it if we are knowing in advance how many times I want to run something. With this, for example, this example, I don't know in advance how many times. That's why I need to use while loop. Clear to everyone? Some people started to be sleepy, by the way. If I see anyone sleepy or kind of sleepy, he has to come up and explain the lecture. Okay, and that's why we use the while loop. The while loop is, this is how we write it, while, and we have continuing condition. So, if the condition is true, we run the code inside. When the condition becomes false, we exit. We don't run the code anymore. Clear? So execute the code. Why the code as long as why the continuing condition is true. Is logical expression any comparison that will give us true or false. So this example, setting the value of I to be 1. After that, while I less than 6, so is it true or false? True. Then I go inside and run the code. Count is the value combined with the value of I. Count is 1, count is 2, count is 3, count is 4, count is 5. After that, when I become 6, is it less than 6? Then I exit. Do you understand? But now notice something. With for loop, the increment or decrement, I have it inside the for loop itself, correct? I have it inside the for loop line itself, increment decrement. Here I don't have the increment or decrement inside the line. I need to have it inside the block of code. So I'm increasing the value of I here, because if I do this, what's gonna happen? It will be.
It will not increment to x equals to 1.
Okay, so what will happen? Infinite to fix, so it goes 0 to 1. Exactly, yeah, exactly. So it will repeat 0 forever. Because I'm not changing the value of 0 of x at all. I said x equals to 0. After that, while x is less than 10. 0, is it less than 10? Yes, go run the code. It will keep doing this forever because I'm not changing the value of x at all. So it will stay 0 forever, and that's what we get. X in loop equals 0, etc., forever. It will not stop. And that's why with while loop, we need to be careful about having the increment or decrement inside. What about this one? What's going to be the output here? If you know, raise your hand. If you know the answer, raise your hand, please. Say again? Yeah, it will work. This one will work fine. Yes. Yeah, exactly. It will run normally. The difference between this code and between this code is that here we don't have the increment. When I added the increment, now it will work fine and will give us from 0 to 9, correct? Now, this is the flow chart for the while loop. The while loop, we start from here. First of all, we test the condition. First thing we do is test the condition. If it's true, then go do something inside the while. If it's false, we carry on the code after the while loop itself. Simple. Correct? But what might happen? If the condition is false from the beginning, what will happen? I'm not going to run the code inside the while loop at all, correct? Because I start from here. First thing I do is to test the condition. And it's false. Do I go do the something? I will go carry on at all. Immediately, sorry. Which means that I don't run the code at all. And that's why we have something called do while. Do while loop always execute at least once. You'll see it. So this is the do while. The do while is do the something that you want to do here. After that, test the condition. If the condition is false, then exit. But at least I run it once. If the condition is true, then keep running it. But the important part is that with do while, I will run the code at least once before I start testing the condition. With while, first thing I do at the top is test the condition. If it's false, then exactly, I finish. I don't run the while loop at all. But here, at least I run the code at least once. Clear? So that's the general syntax for it. So do, we open curly bracket, we write the code that we want to run. After that, close the bracket, we write while the condition. Now repeat the block of code while continue condition is true. And it's a logical expression, it gives me true or false. And that's an example here. Do while loop. So if you know the answer, raise your hand. It's 1 to 5. Exactly. Yes, it's 1 to 5. It's not 1 to 6. I did there. It's 1 to 5. Yeah. I like how you blame him right away. It's him, not me. Yeah, you get count is 1 to 5. Why? I is 1. I will go inside, I run the code once anyway. After that, I plus plus, I becomes 2. 2, is it less than 6?
Yes. Yes.
Yes. Then I go run the code again. Print it. So now I have 1 and 2 printed. I becomes 3. Less than 6? Yes. Could you try this code? You don't have to get a new class inside the existing class. Did you notice what I do when I want to run something here? Where's my Eclipse? All that you have to do is just print out empty line before you do something new, or comment the previous code. Just put comment for the previous code like this, so you don't have to see the output from previous ones. Just see the new output only. Working for everyone who finished? Who has not finished yet? Anyone getting any error or any problem? Leave him alone. It's working for you? Working or not? Okay. Guys, you need to pay attention to you. Not working for you. Yes, because this is one. The one after here. Finish? Running now? You get the output? What do you get in the output? What do you get in the output? What do you get in the output? Count one, yeah. Now I want everyone, after this code, after this line, everyone, please pay attention. After the last line, after the white line, go to the end of this line, go to the end of, put the cursor at the end of this line, at the end of this line, put the cursor there, and press enter twice. Okay, and write the same code that we have this, but using while, not do while. Yes. Write the same code that we have here, but using while, not using do while. Yes. With while, we said while the condition. Yes. You know where people is and where and that way. That's what we provide. That's when I put that mouse here. It will highlight the product goes like this. If I put my mouse here, highlight that only it's the name of you can pay attention to this like a unit. Now, if I put my mouse here, it highlights this for me. You see immediately. You see how this bracket will be highlighted right away. So you'll you see how? Okay, so we need to know where the doctor sub is actually. For now, I ask you to come down here and now write the same code but using while. Who finished? That's exactly what I asked you, why I asked you to do this. So. Guys, if I run this code, it will give me count from 1 to 5. Now, if I want to write the same thing using while, because I noticed mistakes from some of you. While, first of all, let me just add empty line after that. So, while, okay, Zakaria, pay attention. While, I need to have the condition. What is the condition? I less than 6. Okay, let me just have this again because I need to reset the value of I. Okay, less than 6. After that, do what I need to do inside the while loop. So what do I have inside the while loop? Sys out, count is combined with the value of I and I plus plus. So that's the do while, and this is the while. You see the difference between while and do while? I don't have a semicolon here, like what you have. I don't have a semicolon here. And I don't have a semicolon anywhere except the 2 lines inside the while loop itself. Unlike the do while, I have to open the bracket, close the bracket, while I have semicolon at the end here. That's exactly why I asked you to change it to while. To pay attention to this. You see here, I have semicolon at the end here, but here I don't have semicolon. You understand that, guys? You all understand? By the way, this excludes algorithm. You have exercise about it in the lab 2 or 3, I can't remember. Did I give you lab 2, by the way? No. Yeah, okay. Because people, yeah, okay. So I will give it to you today. Oh, sorry. Okay. So the following is flowchart of the do while. Please pay attention. Everyone, forget about what you're doing now. Pay attention. So with while loop, let's go back to the while loop. While. This is while loop. Where do we start? We start with testing the condition. That's the first part. First, we start with the while loop where we test the condition. Now let's go to the do while. Where do we start? Do something. First of all, we do something. After that, we test the condition. If it's true, then we keep doing the something. And we keep doing this as long as this condition is true, unless when it becomes false, we exit. So the difference is in while we start from here, with do while we start with the do something. The code that we have inside the while loop itself, the do while. Do you understand that, guys? So, question. If you know the answer, raise your hand. Know the answer, raise your hand. Raise your hand, don't say it out loud. Say, raise your hand. Yes. Say again. What's going to happen? So what's the answer here? You raise your hand. I'm asking talking to him. Say again. The pin is 0. Yeah. Exactly. So what will happen? I'm saying x equals 0. I will start with the while. I will run the code. So x in loop equals 0. After that, testing the condition. 0. Is it less than 10? Yes. Then I will do the something. Do I change value of x anywhere? No. That's why I will keep doing this forever. And this one will fix it. Here, if I have increment here inside, it will fix it, and it will print from 0 to 9 only. Because first time is 0, print, increase it, 1, increase it, 2, still condition is 2, 3, 4, 5, 6, 7, 8, 9. When it becomes 10, is it true? False, it will exit. Now, if you know the answer, raise your hand. If you know the answer, raise your hand. Yes. It will print only once. Okay, let's see.
No, it will not work, no, because 12 is not less than 11. Yeah.
I'm asking from the beginning. Count is 12. I'm asking no condition. While count less than 11. Is it true? 12, is it less than 11? No. Then it will not go inside the while loop at all. The condition is false from the beginning. That's why we get nothing in the output. Do you understand? Do you understand? No, I'm asking you. Do you understand? Yes. Okay. Now, if you know the answer, raise your hand. Yes.
Print first like count is 12 or something, and then pick up.
Exactly. Because do while, it will run the code at least once. So before testing the condition, I will go from the top. Run the code, system output line count is 12. Count becomes 13. 13, is it less than 11? No, exit. But I will run the code at least once. And that's what I get in the output. Do you all understand? Clear to everyone? So basically, that's the difference between while and do while. Do while, run the code, test the condition, sorry, after the code is run. While, before the code is run. So it depends on where we test the condition. As you can see here, the difference I told you about with while, we start from here. First of all, we test the condition. If it's true, we do the something. If it's false, we go carry on. But with do while, first of all, we do the something. After that, we test the condition. And we use this for you are familiar with them, less than, greater than, etc., etc. Nothing new here. But we have to be careful of infinite loop. Sometimes we need an infinite loop, by the way. The logic will actually dictate that we need to have an infinite loop. But we need to know how to deal with it. For example, here, this one. Why true? The Boolean value true is always true. Is it possible for true to become false at any point in life? No, it's always true. That's why everything that you have here will be true forever. And it will not forever. Unless you have something called break. Remember break that we had in with switch, with the cases? If you have it here, within a condition, it will break the while loop. Okay, I will leave that for you because we have exercise about this in lab 2 or 3, I can't remember. Or for this one, for example, that's another infinite loop. Look at this. I'm saying starting the position is 1. After that, 1. Is it less than 10? Yes. Go and do the something here. After that, set the value of I to 1. After that, we go to the increment. So I becomes 2. 2. Is it less than 10? Yes. Go inside. Run the code. Run this line. Print oops. After that, I becomes 1 again. Go increase it. So it will run forever. So you have to be careful about always you have to be very careful about how you play with the loop variable inside the loop itself. You have to be very careful about this. Otherwise, it will affect the loop behavior. Do you understand what I'm saying here? Don't just shake your head or say yes just because you want to finish. If you don't understand anything, please say it now. All clear for everyone? Now, question. What's going to be the output from here? Yes, X in loop 0 to 4. Correct? X in loop from 0 to 4. What's going to be the output from here?
Pin 0.
So what's going to be the output? X in loop 0 to 4. What's going to be the output from here? Same thing. That's what I want to say. Each one of these 3 loops will do exactly the same thing. Okay? Note that if you don't reset the variable x, here I'm resetting the variable x every time I'm starting a new loop, assuming that the whole this is the same program. Okay, so that's why I set the variable x. And I did the same actually when I was writing the code here. I set the value of x to 0 here before starting the code. But anyway, so choosing the right loop is up to you, unless you are told otherwise. If in an exam I told you, you have to use this one or this one, you have to use it. Okay? But you can do the same with other loops. Okay? Now we have something called nested loops. A loop inside a loop. That's very important, very powerful concept. When we have one loop inside another loop. Loop statement is where 2 or more loop statements are combined together. Now imagine at some point you need to have loop inside if statement inside the other loop. So it will become very complicated. You will have to do that at some point. You will have to develop that logic. So the code block 1 loop contains another loop. A mixture of do while and for loop may be used. So might be. So basically we have while inside for and for inside another do while, etc. It depends on the logic that you want to implement. You will see that in lab 3, you need to do something like this. This is one of the most difficult things for basic programmers or beginners, basically, to start with, but hopefully you will catch on with it. So it's also extremely useful because it has so many applications. And that's the example that I have here. Pay attention to this, please, carefully. Everyone, please wake up and pay attention to this. I have this code, since we have nested for loops, then we have, let's call it outer for loop and inner for loop. Outer, the one at the outer skirt of the for loop of the code, and the inner. So outer for loop, and we have inner for loop. Okay, so this is the outer for loop because it's outside, and this is the inner for loop because it's inside the first for loop. Correct? Now, what is the loop variable for the outer for loop? The loop variable for the outer for loop, what is it? I. What is the loop variable for the inner for loop? J. Good. Now, just like what I did before for the for loop, we start monitoring the loop variable value. So I have I, the starting value of I is what? 1. And the starting J for is what? Sorry. Good. Now, let's start with the outer for loop. I equals to 1. 1. Is it less than or equal to 3? Yeah. Then I go inside. I have another for loop. J. J is 1. Is it less than or equal to 3? Yes. Then I go inside, run this code. What do I get here? So basically, I plus j equals to what? Come on, say it. Yes, what do you think? Why are you asking? Yes, it is. You said it in the way that you asked me. Is it two? Yes. Okay. Now, we have go with the logic of the for loop. The for loop, we need to increase. What is going to increase now? I or j? I am inside this loop. I am here. I run this line. That's why I have now I plus j equals 2. Now this is the output that I have, 2, correct? Then I finish from here. Now I need to continue. My program needs to continue. Where does it go? Does it go back to this for loop or this loop? Exactly. It will continue from the inner for loop. So what is the next value of j? Okay, actually, what is the next value of I and j? I and j. What are the values for them? So I still 1 because I didn't go out to this for loop. I didn't change the value of I yet. Okay, I'm still here. I'm stuck inside this for loop. I have to finish it first before I go out and increase the value of I. I am inside the inner for loop now. So I is still 1. But j will increase to what? And that gives me I plus j equals 3, correct? Do you all understand? What are the next values of I and j? I is still 1, but I need to increase the value of j by 1. So it becomes what? So I plus j equals 4. J, I increase the value of j by 1. Just a second. I increase the value of j by 1. J becomes 4. 4, is it less than or equal to 3? So, which means that I finished the inner loop. I'll go to the outer loop now. I will increase the value of I by 1. So I becomes what? 2. And now I go inside again. Start the inner loop from scratch. It's a fresh start for the inner loop. So j becomes what? 1. So I plus j gives me 3. Do I go to the outside?
No.
Joanne, do I go to the outside now? What do I do now? After this, now what do I do? What do I have the values for I and j? I is what and j is what? And j, not correct first of all, and second of all. Here, after this line, I is 2, you said I is 2, correct? And j will be what? J. I need to increase the value of, no. Joanne, that's why I asked you because I can see in your eye that you don't understand anything. Please come closer. Say again. Come closer. Come closer. Yes, come here. I'm gonna hide you. Come. Okay. Here, I equals 2 and j equals 1, and that's why, because I'm starting fresh with this inner for loop. So that's why j start again fresh. It was starting from 1. And I said I equals 2, that's the outer for loop, but inner for loop j equals 1. And that's why I plus j equals 3. Now, do I increase I? Next line here. I want to tell me what I need to write here. I equals 2 and exactly. I equals 2 and j equals 2. So I equals 2 and j equals 2, because I will still the same. I'm still inside the inner for loop. Okay? But j has to increase this time. So what is j? 2. That gives me I plus j equals to 4. Do you understand? Clear to everyone? Rakib, what's the next value of I and j?
This can be,
What's the next value of I and j?
you stop here.
Say again?
You stop here.
No. Pay attention. We are still inside the inner for loop. So I, does it change? Okay, so I, because we are still inside this loop, we don't change the value of I. We only change the value of I here. But we are not there. We are here. We are still stuck inside the inner loop. Okay? So I becomes, it will say, sorry, will say 2. But j becomes what? J becomes what? Y. You're next. You're laughing. No, you. You laughed. You are next. Why j becomes 3? Okay, you laughed. Answer. Because we are still inside here. J was 2. The next value of j, I have to increase it. So j becomes 3. 3, is it less than or equal to 3? I'm talking English, very simple English. 3, is it less than or equal to 3?
Equal to 3, not this.
I'm asking, is it less than or equal to 3? The condition is less than or equal.
Yes, true.
3. The condition that I have here, 3. Less than or equal to 3. True or false? We have condition. That's math. That's nothing to do with Java, by the way. So I don't have the pen here. Yeah, we have it. That's math. 3 less than or equal to 3. True or false?
True.
That's what I'm asking. 3 less than or equal to 3. True or false? True. Okay? Which means that I will go inside and run the code. So one more time. J equals to 3. Which gives me is 5. Do you understand? Now j, I need to increase the value of j by 1. So j becomes 4. When j is 4, j becomes 4. That's j. J 4. Sorry. 4. Is it less than or equal to 3? That's false. We exit the inner for loop. We finish the inner for loop. We go back to the outer for loop.
Yeah.
What do we do now in the outer for loop? We increase the value of I by what? 1. So I becomes 3. J, we go inside. We start fresh in the inner for loop. So J becomes 1 again. So I plus J equals what? 4. Now, what's the next value of I and J?
3 and 2.
I equals to 3 and J equals to 2. I plus J equals to 5. And last thing, this is 3. And that's 6. Do you understand that, guys?
Yes.
The important thing to understand that when you have one for loop inside another for loop, when we go inside, we have to finish this for loop completely before we change the outer for loop again. So we finish this completely, like what you see here. I says 1 because we are inside the inner for loop now. J changes, so 1, 2, 3. We finish the inner for loop, we go out, we change the I now. The outer for loop. This is the outer for loop, this is the inner for loop. You understand that? Clear to everyone? You say yes now, but I ask you a question later on and you give me heart attack. And anyway, let's hope that's not gonna happen. Let's hope that I'm gonna kill you before you kill me. Come on. Yes, and that's what we have here. So when I equals 1, J will take the values of 1, 2, 3. And that's we get, when we add them up, we get the 2, 3, or 4. When I equals 2, J will take the same values 1, 2, 3, because we start fresh again. That's we get 3, 4, 5. When I equals 3, J will take the value of 1, 2, 3, and that's why we get 4, 5, 6. Do you understand that, guys? Is it clear to everyone?
Yes.
Okay. Now, something that I mentioned last week, or the week before, I can't remember, but I'm going to mention it again. Now, when you have this complicated syntax, for loop inside if statement, inside while loop, inside switch statement, the code will become very complicated. That's why indentation, spacing from the beginning is very important. That I talked about, I can't remember, maybe last week or the week before. In the previous example, we had 2 loops here. So if you have all the code starting here, it will become difficult to read the code, understand what's going on. For Java, it doesn't matter, but it's only for us to understand the code. And that's it. Any question? Any question for real? Don't say yes, you understand everything, and you still have questions. Thank you very much. You know it was gonna be a long lecture. Then let's take a break until 40 and we start with the lab. And take the attendance when we start.